All right, let's quickly review what we talked about last chapter regarding transformations. So if we took our basic function f of x equals x squared, whose vertex is at 0, 0, and we add 2 to the outside, that would move the graph up 2 places, putting the vertex at 0, 2. And then you'll recall the changes to the inside of the function are counterintuitive. So if we subtract 1 on the inside, that shifts the graph to the right 1 place, putting the vertex at 1, 0. And then if you do 2 changes, then if you add 2 to the inside of the function, that'll move the vertex to the left 2 places. And then adding 3 to the outside will shift it up 3 places. So the vertex will be at -2, +3. And then if we subtract 4 from the inside, that'll shift it to the right 4. And then adding 5 to the outside shifts the vertex up 5 places. So that'll put the vertex at 4, 5. And this brings us to the standard form of a parabola or quadratic function. So the standard form of a quadratic function is x minus h, the quantity squared, with a coefficient of a plus k. And you'll recall from the last section, if this is a positive number, your parabola is pointing up. And if it's a negative number, then your parabola will be reflected across the y-axis. Let me draw a picture. All right, if that coefficient is positive, then your graph looks like this. And the vertex is a minimum, the minimum or lowest value of the function. And if a is negative, your graph is pointing in this direction, and hk is the maximum value of the function. All right, before we talk about the next section, let's quickly review the perfect square trinomial. So if you take any binomial and square it, x plus 3 times x plus 3 is x squared plus 6x plus 9. X plus 5 squared is x plus 5 times x plus 5, which is x squared plus 10x plus 25. X minus 7 squared is x squared minus 14x plus 49. X plus 1 squared is x squared plus 2x plus 1. X minus 9 squared so the general form is x plus a times x plus a is x squared plus 2 times a plus a squared. And we can use this to complete the square. If we know the first 2 terms, we can find the third because it's half of this middle coefficient squared. All right, so we can use that to do this problem. Let's take this quadratic function and write it in standard form so that we can find the vertex, which will either be the maximum or the minimum. Of course, the leading coefficient is positive, which means our parabola is going to be pointing up. So that's going to be the minimum. All right, and if you want to, you could hit pause and try this on your own. All right, so we take the first two terms and complete the square. So we take half of the middle coefficient, which is 2, and square it, and then add it and subtract it so that it's unchanged. And then this part is a perfect square trinomial. So we get x plus 2, the quantity squared, minus 34. And now that it's in standard form, we know that the vertex is, and remember it's the opposite of the inside number, but the same for the outside number. And because the leading coefficient is positive, this is going to be the minimum. All right, let's try another. All right, so I would try this one on your own. So we want to take the first two terms here and make a perfect square trinomial by completing the square. So we take half of this middle term, which is negative 5, and then square it, which is positive 25. We make sure to add it and then subtract it so that it's the same equation. So now this is my perfect square trinomial. Don't forget that minus. And so now we can see that the vertex is at 5, negative 12. And because the leading coefficient is positive, this is going to be a minimum, or the minimum, sorry. Because it's a parabola, there's only one minimum. Let's just try one more. All right, write f of x equals x squared minus 6x minus 2 in standard form. Find the maximum or minimum. I would definitely try this one on your own. So we take the first two terms and complete the square. So we take half of the middle term, which is negative 3, and square it. That'll be positive 9. Don't forget to add it and subtract it. So now we have our perfect square trinomial. So my vertex is going to be at positive 3, negative 11. And since the leading coefficient is positive, it's going to be a parabola pointing up. So this is the minimum. All right, a really fun thing to do on a Friday night would be to take the general form and write it in standard form. So factor out the a, take half of the middle, square it, add it, and subtract it. And then you would get your standard form where h is equal to a negative b over 2a. So that's the x value where the maximum or minimum occurs. So you don't have to complete the square every time. You can just use this formula. And remember, if a is positive, it's going to be the minimum. And if a is negative, it'll be the maximum. Let's do some word problems. All right, so let's take f of x equals 10x squared plus 40x plus 5, and let's find the maximum or the minimum. And right away, you can see that the leading coefficient is positive. So that's going to be the minimum. So you could either complete the square or just use the fact that the minimum is going to occur at negative b over 2a. So a is 10, b is 40, c is equal to 5. And as you can see, that doesn't affect the x value of the maximum or the minimum. So the minimum occurs at x equals negative 2. But at this point, we're halfway done because the minimum is going to be an ordered pair. So we need to find the y value. So to find the y value, all we have to do is plug in negative 2. So the minimum is negative 35, and it occurs at x equals negative 2. Let's try another. All right, p of x equals negative 0.001 x squared plus 3x minus 1800 is the number of dollars and profit earned from producing and then selling x cans of soda. How many cans of soda must be produced to maximize the profit? So I would try this one on your own. And the first thing you'll notice is that the leading coefficient is negative. That means our parabola is pointing this direction. So the maximum is going to be the vertex. And you could either complete the square or use the formula that x occurs at negative b over 2a. So we have a is negative 0.001 and b is equal to 3. So my maximum profit occurs when x is equal to 1500. So be careful, 1500 is not your profit. That's the number of cans of soda. that you must sell to maximize the profit. In order to find the actual profit, you have to plug 1,500 into the original equation. And we get 450. So if we sell 1,500 cans of soda, we'll make $450 in profit. And that's the maximum possible profit. So on your graph, that'll be the vertex. It seems counterintuitive, but if you sell more soda, you'll actually make less money. All right, let's try another. All right, you decide to become a pear farmer, and it turns out that the number of total pears depends on the number of trees that you plant. And if you plant too many, then each tree will not produce as many pears. So what number of pear trees planted will maximize the yield? So we have this function, and you'll notice that the leading coefficient is negative. Let's write it in the correct order. And because the leading coefficient is negative, we'll get a parabola pointing like this. So we're looking for the maximum, and you could either complete the square or use the formula. So the negative of the b over 2 times a gives you 50. And remember, that's the number of trees that will give you the maximum number of pairs. In order to find the maximum number of pairs, we have to plug this into our original function. It's going to be negative 8 times 50 squared plus 800 times 50. So if we plant 50 trees, we'll get 20,000 pairs. So that's this point. And again, if we plant more trees, we'll actually get less total pairs.